So this is the fourth session on digital communications, and we are going to study the block diagram of a receiver. Now the study of blocks in the receiver will be comparatively simple because we have already studied all the transmitter blocks in some detail. So this study is simple because every operation in the receiver will be inverse to the corresponding operation in the transmitter, and also overall the operations are in the reversed order. That is, remember, the last operation that was done at the transmitter was modulation. So in the receiver, the first operation that will be done will be demodulation, and so on. So considering all this, let us start. So this is the entire block diagram, and let us see what each block does. Antenna will consider the electromagnetic wave as the input and generate an electrical signal at the output. This is the modulated signal. Usually after the antenna there will be some amplification, but in order to keep the block diagram small, we have omitted that. Usually there would be an amplifier here. And this is a modulated signal, and you want to obtain the baseband signal, so you have to do the reverse operation, that is the demodulation. So demodulator is the circuit or the program which does that. So as we said, this recovers the baseband signal. Then equalizer is a kind of filter which is designed in such a fashion so that the inter-symbol interference which we discussed in our last session is minimized. So let's repeat that. It reduces ISI or reduces inter-symbol interference. Then we use a matched filter in general to get the SN ratio which is maximum. A normal filter also could be used, but then the noise performance will not be as good as you obtain in a filter called as a matched filter, the study of which we will carry out in detail later on. So the matched filter is required in order to improve the SN ratio. Then, having got the output from the matched filter, you have to take the decision whether the received waveform is 1 or 0. So it has to be compared with a threshold, and that is what the decision maker does. Okay. So at the output of the decision maker, you get a stream of bits. Now these stream of bits that you obtain are coming from various sources, but you are interested in the stream which is intended for you. So therefore you have to do what is called as a demultiplexing operation, and the circuit that does it is called as a demultiplexer. So that is what it does. It extracts the desired signal from a signal which is a combination of signals from many users. Then error control coding was done at the transmitter, so you have to do the reverse operation here, error control decoder. So this will look at the input bits and perform an algorithm which will correct the errors which might have occurred because of the noise. Then you have a decryptor. This uses a key to transform ciphertext to plain text. Remember, encryption was done at the transmitter, so the corresponding inverse operation you must do at the receiver. And generally a key will be used to transform this ciphertext, that is the encrypted text, into plain text. Then you have a source decoder. Remember, source encoding was done at the transmitter, so you have to do the inverse operation at the receiver, and this reverses the compression and recovers the original information. So the output of the source decoder now goes to a digital to analog converter. You get your analog signal here, and it will go to an audio circuit. So that is how the signal is processed in the receiver, right from antenna to the audio circuit. Now understand that here we are assuming that we have a radio channel. If we don't have a radio channel and if we have line communication, then of course the antenna will not be required and your signal will be injected right at the demodulator. And at the output in general will not necessarily go to the audio circuit, it could go to a display. But otherwise, the operation of all the blocks that we have considered remains same, whether it is audio that is being transmitted or some other signal that is being transmitted. So this completes our study of receiver blocks in general. Understand that in this lecture and some of the preceding lectures, we have been basically giving introduction. So all the blocks we have studied in short, and in our later sessions we'll be studying each block in some detail and also see some applications of these concepts. But for now, that's all.